Hi, we're Lexicam, a tool that's supposed to help young readers define confusing words as they're reading any kind of physical book.
Hey Lexi, what does this word mean?
A toadstool is a mushroom that you shouldn't eat. It's often poisonous.
Hey Lexi, what does this word mean?
A moose is a really big deer with huge antlers, like big, funny looking horns, on its head.
All right, now we're going to go step by step how this process works. So from the demo that you saw that the very first thing that we did was point to a word. But before we did that, we had our hand come into the screen, and you could see that we're able to track that the hand is in the screen and what landmarks are on the hand. This we do using MediaPipe, which is Google's hand landmark detection model. And we can see that we have each of the landmarks on our hand detected. And once we point, we say, "Hey, Lexi." And this is a vocal trigger that we have coded in for Lexi to start noticing what you're pointing to. It basically, when you say, "Hey, Lexi," it detects that. And the way that we have it detecting is using the trigger Lex, because we found that Lexi could be spelled with an I or a Y after the Lex part. So once it detects Lex in the audio, it starts the process of capturing the scene and moving on to the OCR, which Esme will talk about.
Cool. So once we have this situation where we're looking at our pointer finger pointing to a particular word, we care about the two top coordinates on the pointer finger. So you can see this is the tip, and then we have the middle coordinate. And what we're going to do is we're going to draw the line between these 2 points, and it's going to go up until you hit the nearest word. And the way we detect that is via OCR. So the first thing is we isolate the image like so. So this is an image that we've seen before of a hand pointing to the word troll. And so then we collect the landmarks. So these were the top two landmarks that I mentioned earlier, the X and Y coordinates of the hand. And then we do things like shadow removal and OCR using a Python package, and we segment the text into individual words. So I'm pointing to the word troll that's highlighted in blue, and you can see there's several words around it in red that are also highlighted as part of our context. So now what we're going to do is feed in this target word and the surrounding context into Gemini 2.0 Flash, which will help us generate a definition, as you can see here. So we have our word, we have the definition, and this is actually read aloud, as you heard in the demo, to the child, which is great. Gemini is also going to generate an image for us that the child can see. So you can see this is a fun, child-friendly image of a troll. And additionally, we have an image caption that gets generated. So this is just a description of what's in the scene for extra information if it's needed. So this was an example with the word troll where actually we didn't technically really need the context to define the word correctly. But let's take a look at an interesting case where that might be useful. So in another example, let's say in the same book, we're pointing to the word trip, trap, trip. And maybe it's not necessarily clear what this means. So what happens is, again, we do the OCR to get bounding boxes on everything. And we've highlighted the surrounding context. So it goes from when to on, including trip, trap, trip. And so then we're going to pass in, again, the target word and the context to Gemini. And Gemini is going to give us an image. So this is hooves trip trapping, which is great because that was actually part of the sentence. And then again, we have an image caption in text that was generated as well.
Thank you for the overview. We're going to talk about two interesting failure cases that came up while we were doing our user studies. The first one relates to something that falls out of the scope of our current system, but we would want to broaden the scope to eventually support books like these that are geared towards younger audiences, but the text within them is packed dense together, so the OCR isn't able to recognize it from the height at which we have the camera set up. So when the user tries to point to an unknown word and trigger Lexi with the phrase provided, Lexi isn't able to see a word because it sees an untype instead.
Our second failure case is even more interesting. So in the case where this landmark here were to be positioned here, which is still around the joint of the finger, what our system does currently is it looks at the trajectory that would connect these two dots to find the correct word. So if while landmarking, this dot ends up here, this line would lead to a different word potentially. And this has occurred in one of our user tests. And it was interesting to see that while the user was performing an action that should result in a correct output from Lexi under the current scope of our system, because of these unforeseen landmarking issues, we have another unexpected factor to consider. Something we could do to prevent this is maybe corroborate with another landmark, like use this one, and this one, and maybe average those trajectories. But currently we are facing this error, and it's an interesting and unexpected one. Thank you.
Thank you so much for listening.